Audio check. 1, 2, 3. Okay, sounds like it's good. So we can get started. Ladies and gentlemen, welcome to the stream of the Discourager of Hesitancy, where we are building software with the least number of things we can pull in. So in this case, it's a game with no game engine. Wrote everything from scratch with 4-ish dependencies. We have all of the core features done, and we are in a bit of a cleanup phase for the next day or two. And if that goes well, we might implement a couple of nice-to-have features. Then we'll be into the polish art cleanup phase while I start up the business side of things. So that's kind of where we're at in our little mini roadmap. Yesterday, we fixed a couple of latent bugs. Nothing too crazy. Nothing worth writing home about. So today, let's go check our to-do list. Technical debt is mostly what remains for this cleanup phase. I'm thinking the shader uniform locations might be good. These green space scaling calculations are scattered all over, one per scene. I did actually localize things pretty well into a do layout function. So maybe it's not that bad, but we are going to move an awful lot of math into one location. Because it's duplicated and spread all over, because I haven't felt like dealing with it yet. So maybe we'll get those two things done today. We'll feel pretty happy. Let's grab those. This, I don't know if we'll ever solve. It does have more draw calls in the settings scene, but like I don't think it should make that big of a difference at the number of calls we're doing currently. Although we are probably render limited, and not anything else limited. I don't know. There's a lot of things we could do around that, but maybe it's not important. 1,000 frames per second is plenty. Then yeah, these are kind of our nice to haves. It would be cool if I could implement them, but we'll see. So that's where we're going to start. Good news, good news. I think I've finally got into the Twitch affiliate program. So I can now make money as a streamer. I can become a professional streamer. Honestly, don't give me a sub or anything unless you actually want to and have the money to spare. If you happen to have an Amazon Prime sub laying around, great. But like, I want to make money selling games, not necessarily for the streaming. So nothing to worry. We're gonna keep doing this for a while. What else? What else is new? I totally forgot to put out my month 3 code report on Twitch, so I'll do that sometime today. I cannot work past 5 today, so I will have to be disciplined. I have a meeting this evening. I think that's it. 4 announcements. So let's get started. Read this thing, we're going to look at shaders. We can start with the color quad, I guess. Fragment shader, color quad vertex shader. Okay, so shader uniforms. They have a location in memory on the GPU. Now, I am limiting myself to OpenGL 3.3 so I don't get dragged into a long, dark over-exploration of OpenGL. That will be coming. So, in version 3.3, me specifying the locations of these uniforms is not part of that core feature. So we have to declare an extension saying, we know this isn't part of 3.3, but most GPUs support it anyways. So just tell the GPU we're doing this even though it's not part of 3.3. And generally I'm okay with that sort of behavior, but like I said, I'm trying to limit myself to 3.3 core anyways. So I think I want to get rid of these extensions that I put in all the shaders, which means we cannot declare this location like this, which means we actually break everything on the, well, in a few places. So let's see, color quad. Here's the uniform. So we're going to start with this. This is where we're starting today. So that was color quad. Let's do texture. So remove it from the fragment shader and the vertex shader. Okay, what other ones? We need text fragment shader. Delete the layouts. Okay. Last but not least, texture batch. I think that's most of it from the shader side. Did I miss any? Text B, yeah, okay. Which brings us to this part where we were looking for the word uniform here. So we are taking those shaders and we're embedding them in our actual code, which looks something like this. Shader warehouse, where we declare the asset, the shaders, the uniform locations. Then we can get our shader out of here. So that's gonna have to change. So first thing is all that goes away and we can no longer get a location. maybe what we do location, I don't think. So the question is, does this already exist in our uniforms? Oh, fun. Or we can emplace it. If we find it, fine. If we don't find it, we put one in. You do call that. Okay, so for right now, every file has its own list of uniforms. So I think what I want to do it's not location, index, and its current location index. Oh, not index. Int uniform count. That's probably what we want. And if we found one, uniform count increments. Okay. So that's part number one. Each file finds its list of uniforms and we keep them in an order. Do nothing. Already inserted. Okay. Which means really we have to only increment the uniform count after we do insert. There we go. Perfect. There. Now it's going to write out. It's in here. It's times like this I kind of wish I had my code snippet thing from the compiler. The source file. Where's my header file? There's the assets. Fine. Uniform locations. This is going to be different. So for each shader pair, so that's our vertex shader and our fragment shader, those were new. The GPU, the graphics processing unit, takes large chunks of data and turns that into the pixels on the screen. And the way it does that is there's lots of ways you can do things, but the most common is you have a vertex buffer, which says here are the corners of triangles, and here are all the properties of each corner of each triangle. So that's your vertex buffer. It tells you about the vertices you want to draw in some world space, right? So whether you measure it in meters, whether positive y is up, that sort of thing. You define that. Then you feed all that into the vertex shader and it figures out which pixels on screen need to be colored. And it's not quite accurate to call it a pixel, it's a fragment shader for a reason. But you can roughly, first order approximation, call one vertex a fragment. So one pixel, not vertex, one pixel, one fragment. That's not true. In fact, in our case, I think it's set for four fragments per pixel, but that's a separate. That's more detail than we care about right now. So it goes to each pixel and says, what should I draw here? So you need one shader to do all the math about the vertices and another shader to do all the calculations about what colors to put where, based on the vertex. So the GPU is a pipeline. Things go from stage to stage. It goes, your buffers all go into the vertex shader, then it adds a bunch of data to each fragment shader. And then the fragment shader actually writes the color for the output. So that's roughly the story there. Okay, so we're going to have an int uniform count equals 0. Oh, we're sorting them? I do not want to sort them. Okay, so we are not going to do that. I'm not going to do this part at all. We're going to go pair uniforms. Oh. Okay, I do know why I did that then. Oh, bother. Okay. Let's comment all this out for a second. Now let's just write out in our help file. We want to write out and this can be an enumeration. So let's do that. So an enum class uniform IDs. Okay. And then for each thing we will put out, what is this, 4 spaces? 1, 2, 3, 4. Yeah. 1, 2, 3, 4. 1, 2, 3, 4. Modulus S, modulus S equals modulus D, comma. Oof. It would be nice if I could tell if I was at the last one. How can I tell if I'm outputting the last uniform? Oof. let's just do this way for now. So for each shader pair, so let's go look at our definition for that thing. Oops. We have vertex key, vertex file, frag key, frag file uniforms. Vertex key. Maybe use the vertex key. And we can use both vertex and fragment key. That is probably correct. So the shader pair, because a uniform location is shared between a vertex and a fragment shader. They come in pairs. Shader pair dot. I want to do the vert key first, then the fragment key second. Just so we can see that things are happening the way we expect. Let's see here. Build target equals embed shaders. Yeah, that's fine. Okay. cd tools bin dot slash embed shaders. Then we can open up our shader warehouse. Uniforms found in shaders. So there's our pair of shaders. And then that thing. Okay. So two, three. Actually, it's fine. It's fine. Let's see here. The reason for this sorting is so that everything is based on that uniform, which in this case is our index, right? So we can now put those this way. Okay. So this part actually stays. Not doing this anymore. We'll do something else, which will be something like this equals modulus d, which will be shader pair dot. It cannot be in the vert key. Anyways, then the pair dot first, pair dot second. So each pair is the name of the uniform, and then what's the value in the second one, plus uniform count. After which uniform count is bigger. Pair vertical key for key size of characters. So pair.first.c string. Forgot about that. Okay, vert key will not work for us. We need something better. Oh, Dravest, how are you? I'm good. I'm good. How are things over in sunny Sweden? Although you said you're headed into cooler weather finally, so that's good. Shader pair. Let's see here. Read input file. So one thing I'm pretty sure we insisted. Our vert key and our frag key have to start the same. Is that true? Enum class asset is very close to what we want here. Let's just find the first underscore. Let's try that. Okay. Too many arguments. I don't believe it. So the shader pair. Yeah, the new line stuff. That's not too bad. Pretty good here as well. Yeah, it's a little cooler, but still pretty sunny. It's really beginning to turn into autumn now. Nice. Yeah, I've noticed my bike rides and my runs are much more enjoyable. It's warm enough that it's not uncomfortable. It's cool enough that it's not uncomfortable. It's perfect. Okay, it is finding the wrong thing, so let's go to put a dot index -2 -1 -2. So we're going to find that dot and back up 2 characters to take off the V or the F and the underscore. Okay. Texture, text, MVP, text batch textures, text batch MVP. Good. Let's get a little bit of spacing around here. Bool first shader equals true if we're in the first shader. This is fine. Otherwise, we want an extra blank line. Just a little bit of visual breaking up. Yeah, so text, text batch, color quad, and text. There we go. So we're getting those enumerations to pop in. We need to throw some commas in. Then the hardest part is this thing does not need a comma. The last uniform of the last uniformity. The last shader file. So shader index equals files dot size, which I think is a vector, equals 0. Shader count equals files dot size. That's what I wanted. Okay, once we're in a shader, we have this vector of uniforms here. So we can have a int uniform index equals 0, uniform count equals 0. Ooh, not this uniform count. Let's rename this one. Uniform offset. Uniforms dot size. Plus uniform index. Plus shader index. Okay, now if shader index is equal to shader count minus 1 and uniform index equals uniform count minus 1. Then we do that. Otherwise, we do this one with a comma. What are the odds? What do you think? How are we going to do this? Let's see if that works. Okay. Commas are all in the right places. Now, I'm looking, the way I've written this, I would expect these numbers to just increase. 1, 2, 3, 4. There's no 5, which is a little puzzling. 7, 9, or 11. That's not good. There's 9. I say. 10 and 12 are duplicates. We want each of these to be unique and contiguous. Oh. Okay. I think I know what's going on. Okay. Basically, we're double incrementing. So, veg shaders. Uniform offset. Plus equals uniform count. Zero, 0, 2, 2, 4, 5, 6, 7, 8, 9, 9, 10. Okay. Or literally just do this. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now, in theory, in text, this is the order we discover them in. So, we're going to the text fragment shader. Our uniforms are, or rather, text vertex shader. Our uniforms are texture, Now I'm a little bit confused. I mean, this is fine. Maybe we sort by name. We can sort by name. Kind of doesn't matter. The second values are not comparing the way I would expect. Just sort them by name, maybe. So I'd expect MVP texture, MVP textures, clipping enabled, MVP clipping rectangle, MVP viewport, clipping enabled, clipping rectangle, MVP texture viewport. Yeah, so that's all sorted alphabetically by file, so that's fine. Yeah. So what we're trying to imitate here is a range checked uniform, which is going to look very similar to the image warehouse, where we have all these UV keys, and each UV that we have has a key that associates with it per file. But if I was in a different file, if I had, button H edges, and I tried to look up top left normal, it would not work. It would fail. I don't remember exactly why UVs to the asset. Not sure I remember. Oh, here we are. UV start index, UV count. That's what I need next. Entry uniforms start index. Uniforms count. Okay, let's compile run that real quick. There we are. Uniform start index, uniforms count. Those should be private, I think. Okay. F written. Always a problem. I can't spell. My fingers are dyslexic. That's what I'm going to go with. That should be everything we need in the header file updated. I don't remember. In image warehouse, I do have UV names. And a UV count. Okay. This makes sense. We need to do this. Except slightly different, but it's fine. Equals some number. These are not UVs, obviously, but we'll make it work for now. UV with uniform count, uniform names. Uniform locations. Do the old uniform offset. I think that's just the number here. Boom. Everything else in there should be fine. Okay, so let's check that out. Uniform count 14. Is that true? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Correct. And we should have uniform names for all of those. Uniform start, count, and the actual locations, which leaves an integer as well. Okay. So that's the header file basically wrapped up. In my image warehouse, get UV name. Those all seem reasonable things to implement. Okay. I call those uniform IDs. Uniform ID for shader. Uniform ID count. Uniform ID name. Get uniform ID location. This one is integer. There's our asset. Our uniform ID. Okay. I think if there's anything else I need to know here. I was capturing, let's see here, where we were reading the file. We do have the uniform type. which we never actually use. We do remove the array chunk. So we could get some more information in if we wanted in one location. That's an intriguing idea, but I don't want to get bogged down. So let's to do uniform type should also be available to output. Because we capture it, we're just not doing anything with it. But then if there's a bracket, we should mark it as an array. So it'd be like, if it's an int, it would be an int array or a sampler array or something. Uniform type should be marked as array. Okay, so that'll be a nice quality of life improvement for that. We need the uniform names. And these. Basically, we need to initialize all of these at the top of the source file. Declare all of these in our source file. I think that's, yeah. Yep, just grinding away at this. Where are we at? There we are. Output uniform related things. Those can be static. Not static. These can be constant except for the locations. Hmm. Okay. Oh. Namespace everything. Okay. Okay, right. Oh, okay, let's see. Right here. Up there. Right here. Mm-hmm. Read input file. Here we are. Oops. Mm-hmm. Where do I create shader definition pair? Files dot pushback append. Mm-hmm. Read input file. Oh, there it is. Here, I guess, is where this needs to happen. Okay, shader definition also needs HR, UV, oh, not UV, uniform key. String copy into result dot bag dot uniform key, this temporary thing, and then we can delete this temporary thing. Okay, then in right header, temp is not a thing, rather it is shader pair dot uniform key. Or uniform or prefix, maybe just prefix. Let's see here. Temp with prefix 1, 2. Okay. Because where we write out this thing, found contents output. Here we are. We want to again result dot back. Prefix was not declared. I agree. Shader pair dot prefix. There we go. Okay, so that all still looks the same, which is good. These are all still here. Shader warehouse, CPP. We get here. Okay. Perfect. Question mark. This one was going to follow a very similar pattern to where we define this enumeration here. Very similar. And steal some of that code there. Cheers. In fact, why don't we just steal all of this for just a second? Uniform names. It's going to go right in here. I think we need first shader node. Let's not doing this. We do all of that. Then this is just a string with no comma, or a string with a comma. Put a dot instead of an underscore. Uniform offset is not a thing we need now. See how that works. It did nothing. Dum dum. Okay. Files. There's simplify this a bit. Maybe means we don't even need this. The strings should sort fine. Shader is not declared. I agree. Oh. Included things from the wrong place. Uniform offset equals 0. Including things from the wrong loop. Huh. Enum class, uniform ID, fine. not. Keys. Sort of. On a thing. Shader pair dot prefix. Uniform dot c string. That's a little bizarre. Text batch color quad text. But no uniforms. Um, that's just bizarre. Okay, well, where do we find uniforms? Data size. Huh. We must find uniforms. A slightly different manner. Can't find him here. Can't find him somewhere else. We don't have the information we need at the time where we write that file. Oh. Okay. So find uniforms needs to happen. We are reading the input file. Where, oh. So read the input file. Okay, so create our prefix. We did our temp. Then we need to read in a file. Build on back uniforms. Data and data size we must read. So I get to read a file twice, which makes me sad, but this is not time performance critical, so I guess we forget that. As far as performance goes, we're gonna ignore that for now. Then we delete our data. Right, data. Name text file. File name, which result dot back dot vert file. Frag file. Is that it? There we go. Now I've got the two pronounced I expected. Meanwhile, shader warehouse.cpp. There we go. So our texture quad shader dot MVP is our uniform text batch MVP and textures color quad. Yeah, okay. So this looks like reasonable names for all of that. Okay, not bad, not bad. It's shaders. So for this one, I'm just gonna do that. Okay. And uniforms start index. Is that something I want to keep track of? So for each shader pair, for each vertex and fragment shader, we want to write the same number twice, which is fine, because that's on a per asset basis. Get uniform offset equals 0. And our shader index equals 0. Let's put shader index. If shader index is equal to shader count minus 1. It will be one thing, otherwise it will be something similar but slightly different. Okay, now what we're going to put in here is a uniform offset, uniform offset. And then we're going to uniform offset plus equals shader pair dot uniforms dot size. Let's see how that works. Shader pair dot vert key okay. There we go. How do I do that? Looking for uniforms. Okay. Then come over here, nothing should have changed as far as that's concerned. Shader warehouse CPP. These are all in there. This is not updated at all, but are these numbers correct? So if we shader warehouse header, this first file has 2, the next file has 2. So we start at 0, then it's 2. So that should be an offset of 4, and then we add 1, 2, 3, 4, 5. So an offset of 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's correct. We just have some weird goofiness there. And these ones are over indented. Okay, this is always a comma. And it should all be indented 4. Okay. And then up here, this indent is too much. 1, 2, 3, 4. 1, 2, 3, 4. Okay. All right, these look good. Uniforms count. It's going to be very similar to this thing. Let's go do that. Okay, we don't output an uniform offset. We instead output shader pair uniforms dot size. That's basically it. Okay. So that's all good. Should be like 225 and something. UX unsigned has map size type long unsigned. Okay, fine. Hint. Two, 2, 5, and 5, I guess. Shader warehouse. 1, 2, 3, 4, 5. Yeah, that's correct. Cool. So got those. Next, uniform locations. For each entry in our uniform count, we just put a number in. Now, 0 and above are basically valid locations, so anything negative means an invalid location. However, However, I would like a special number for, we haven't looked up this uniform yet, which is maybe hex 2's complement. I think I just want in hexadecimal F 1 2 3 1 2 3 4. In I wanted to unto's complemented though. Okay. I don't need a calculator. Programmer calculator. We're gonna go hex F 1 2 3 1 2 3 4. Then we will bitwise not -1. Yeah. So it's literally 0 1 2 3 1 2 3 -1. Enter. So if I remember right, I think F F F F F F F F not -1 is a special number. So not. Okay, damn it. So what's F F F F F F E decimal 2.68 billion million. That's only 32 bits. That's not really enough. E. I need a good negative number. What's a good negative number that I have control over? What's a good negative number? So like -1 means something. Negative something else. An easy bit pattern that I can learn. Let's see here. 1 2 3 4. 1 2 3 4. 1 2 3 4. So that's 32 bits, which is decimal -1. Okay. So that one I want to keep safe. I want F 1 2 3 1 2 3 4 1 2 3 4 1 2 3 4. A 2-bit number. Ooh. So it's F F F F F F F. Which is this number. think that is a unique number. Okay, but we do want to label our uniforms in the same way we do here. This is modulus D, and then the key. Prefix thing and basically this number. We 0x 0 8x. Zero 8x. Let's just try it and see what happens. Okay. Sort of. So shader index equals 0. Then that was a mistake. And do we need a uniform index? Oh, we do. Yep. Okay. Okay. So shader warehouse now has a number in it. How do I feel about that number? Six. Okay. So that is our initial value. Okay, then these functions and embed shaders that we have right here. Most of these are fairly trivial now, actually. So we're going to go to get index. Put this stuff right here. I'm going to implement it. All right. Whoa, TCAP. Hey, how's it going? Azenris, Arasuus, Solfam. Holy raid. No kidding. Man's locked in. Yep, afraid so. How's it going? Keycap, welcome, welcome. 34, holy smokes. Well, welcome aboard. Do you want the whole spiel? We're making a video game with no game engine. And we are right now in a phase where we've got all the features we want. We're doing a bit of a polish phase over the next couple of days. So we're going through my technical debt, bugs, loose ends, trying to get those wrapped up. If we do that quick enough, we're going to go add a couple of nice to have features. And so like here's some of the tech debt things we're going to work on the next day or two. If we have time, we're going to scale our sound playback with time as we warp time. And we might implement some spreadsheet animations if we have time. But what we're doing right now is I limited myself to OpenGL 3.3, and I cheated. I used an extension to allow me to declare the location of my uniforms. So what we're doing right now is we're removing that, so there's no extensions, just OpenGL 3.3. And that means I have to change my asset pipeline to handle the uniforms differently. It's parsing them out of the shaders and dumping in a location into my embedded code in my executable. So that's what we're doing right now. Is we are updating our asset pipeline for when we embed our binary data. How are you all doing? What was your project today? How was the stream with TCAP 1? Yeah, no engine. I look at, Unity or Unreal, and even just an empty scene outputs hundreds of megabytes. So each week I check my frame rates, I check my executable size. Right now we're sitting at 14 megabytes. That's including embedded images and sounds. So we'll see where there's an optimization pass towards the end where we're going to try and compact that data. Right now it's all raw image data, just 32-bit RGB channels. We'll pack it down a little bit. Same with the audio. I think almost all of the audio I have is probably mono channel or could be mono channel. We may also go from 16-bit PCM to a MULA encoding. So all kinds of things going on here. I figure in another couple months the game will be completely done and maybe launched. So something small, like when you start a new project, scoping it small is kind of my goal. A lot of people jump in and try to create their magnum opus right away, like Amazon. Throw $1 billion at something and have it fail. No fun. So I'm just spending, 3 to 6 months, something small, crank it out there, get it on Steam, go through the whole process. We'll do something similar for a second game, small in scope, more as a learning and practice. And then we'll pick it up to something a little more ambitious on our third project. So that's where we're at. What I usually do is I just kind of code stream of consciousness until somebody asks a question. I'll explain whatever I'm doing as I go. Pop a question in and I will answer. So we're going to write some code which writes out code. We've got our new uniform handling stuff kind of in place. Oof, let's see here. But we need to make it respond a little bit differently to things. So, so that's the Plan, welcome aboard. Hope you enjoy the ride. Yeah, just let me know if you have any questions. So the way we were doing it was we would parse out the location. Let's see, can I find a text fragment shader? So these uniforms used to physically specify their layout, and then I would parse that in my asset pipeline and just embed that value in like, not an enumeration, but a constant integer. So what we're going to do is we're going to not supply those, which means the first time we look for a uniform for a shader, it's going to have to look for it. And then once it's got it, it's going to cache that value, so I don't have to keep spamming the GPU for locations. So these functions are going to help us do that. So return, this has a name, it's called uniform, I don't know what it's called now. XYZ, it's called entry uniform start index. I don't think this is as helpful as it was for the UVs. So we might as well supply them the same. Shame that OpenGL 3 doesn't have those explicit locations. They're very convenient. Oh, no, totally. Like, they're super convenient, and me removing that dependency is literally just me being, needlessly trying to get rid of extensions, right? This worked, it's fine. But like when I first started the project, I really wanted to keep the OpenGL side very small and core. Like, I've only got 4 shaders, dead simple. It's all 2D stuff, anyways. You know, just an homage to a game from back in the like early '90s. So this is not necessary, but and in our next game we're definitely using it 100%. Over this one, like I set a goal, keeping it 3.3 core, and I felt dirty about using the extension. So that's all. That's why it's in the loose ends, technical debt kind of thing. To steal this. Okay. So that should be most of that implemented. I feel like uniform ID location. Okay. All right, so this is the part that's the only major trick. Without VAOs and all, no, we're allowed vertex attribute objects. That's fine. Vertex array objects. Those are in 3.3. I find it fascinating to imagine that people used to program even in OpenGL 2. Yeah. So part of the reason that I deliberately scoped this project so small was the last time I did OpenGL in any meaningful fashion was in college. So, 20 years ago, almost. Back when we still had to use GL begin and GL end. So I'm trying to keep my scope very limited. I will spend some time between game 1 and game 2 actually learning more modern OpenGL. So I did have that early experience trying to render I believe it was a mathematical equation for a Nautilus shell. It was pretty cool. It was one of the projects. made us write our own graphics library that did what OpenGL would do. So we had to write to our own texture without OpenGL. Always fun. Learned a lot that way though. Yeah, it's been so long, like even that experience, I don't hardly remember the details anymore. So yeah, I'm probably doing a million things poorly in OpenGL right now, and I'm okay with that. Our frame rate's still, over 1,000 in the worst case, and we're just gonna live with it for now. Okay, so we had something similar in our image warehouse. So we embed our images. So for our images, similar thing. We have our UVs all defined by a number. You can look them up. Our image warehouse is a little bit larger. This is another thing we'll have to compact, but that's fine. So here's the trick, is that I really, we're mostly going to copy that and just see where we go. So we have an asset, and it needs to be in the thing. I'm fine with that. The uniform ID. Honestly, I shouldn't have to do this range check. Oh, this range checking I do have to do. Okay, so UV index can get turned into uniform index. Okay, so the other reason for this was that we have a default UV for the way that I usually lay out my rectangles that just matches the whole texture, so we don't have to, subsection out images. So this actually goes away. We don't have to check that because our uniform IDs are not the same. Okay, so we're gonna replace that with this. Entry uniform count, and there we go. Entry uniform count index plus uniforms start index. Okay, if that's the case, we do some things, which is not this. Otherwise, we can log an error. For get uniform ID location for some image, uniform is invalid. We need to escape our quotes in here. Be something like this. It was pretty close. Right. Okay. Code. There's a piece of code I wrote on another project. So I do game development Monday through Thursday. Friday is compiler day where we're building our own tokenizer generator. I wrote this piece of code that like does little code snippets and things, which I'm really wishing I had right now in this project. So that might be the kind of thing I do over a weekend. That's nothing anybody needs to watch me do. It's kind of boring, but it would be super useful. For shader, whatever. Uniform is invalid. Next key map index. Get uniform ID name. Uniform ID UV index. Just index, I guess. No, uniform index. Okay. Let's see what that outputs. Okay, so we did forget to do some of the namespacing things. Class label. And this one. This one. Yeah, because one of the things in my code snippets piece actually would do the replacement for me. 1, 2. Oh, wait, no. Okay. That one's fine. For shader, whatever, uniform, whatever, is invalid. Okay, so we really only have 1, 2, 3, 4. 1, 2, 3, 4. Maybe. It doesn't believe me. 249. Ooh, got that one. Means I've got that one and that one. Okay. So let's see how that works. Shader warehouse. So yeah, here's our shader code embedded. Just a single string per file. Vertex shader, fragment shader, it's all there. So there's my uniform. So we're doing all 3 locations. We're doing that. Okay. Embed shaders. Right. Here and here and here. So what is TCAP working on today? If I remember right, let's see. And I've watched too many, I'm afraid. TCAP. Was he doing the tower defense? Is that the? Is it a tower defense game, right? Yeah, C++ tower defense. Perfect. I do remember. Good. I hate it when I get people confused, but okay. Yeah, it was looking pretty good last time I looked. Data warehouse. Okay, that's looking more correct. Sort of. Actually, don't like that. Shader code. Yeah, I think I want to change those the way that that outputs. Let's put those 3 lines back in where we output here. We do that. I think that's what we're going to do. Okay, now hey Pat, what's up? We got raided, man. And we're retooling our asset pipeline for shaders to get rid of the extension we were using. Not the top priority, most important task, but you know. Yeah, so the reason I want the bracket outside this is it just looks funny with the comment right after it. These ones kind of self-label themselves, so I don't feel like there's any need to, yeah, close those brackets off. This is just a little bit cleaner, I think. Okay. Which means the function we're most interested in is somewhere. Okay, so we get our asset and we look up its index. We assert that it has to be within range. Fine. I'm not sure that's necessary. We get our uniform index from our ID, and then we say if our start index and that index. This looks unwieldy. I think I want to rewrite this just a tiny bit to make it a little more readable. Get uniform ID location. Okay, so what we actually want is an int start index equals just the index. Count uniforms count. Then if start index is less than our uniform index and uniform index is less than start index plus count, then it's in range. And that actually gets rid of all these class labels. Puts down one here, one there. I think that's going to be more readable. Which brings the whole point. The whole point here is if it's between that range, we can return the thing. Except that it's not quite that simple. We have to see if we've already looked it up. So we're getting a uniform location. See how we were talking about being swatted? No, not yet. I don't think anybody knows where I live yet, except people I'm related to. So hopefully they don't swat me. I don't want to get uninvited to Thanksgiving dinner. Yes. I was afraid I was a little bit in the zone when they dropped in, so it took me a minute to catch on. I haven't set up all the fancy bots and things to warn me when that happens. So for those that are rating, I've said it before and I'll say it again, I don't think of myself as a content creator yet. I just think of myself as a programmer who happens to stream. So you're not going to get a very polished experience here in terms of that, I'm afraid. But we will write a lot of code and answer a lot of questions as they come up. Okay, so we just outputted something. Uniform locations. Uniform index. If this is less than 0, I have to do some things. Otherwise, just good to go. Okay, so if our uniform locations is less than 0, we have a question to ask. The question is, have we tried to look this up before and failed? Then we will just fail silently ourselves. Otherwise, we'll go try to look it up. It's less than 0. So the question is it equal to -1? So -1 is we looked and did not find value. Which basically means fail silently, I guess. Fail silently. This was already looked up, failed, and logged. Otherwise, this is where we do the lookup. Do the GL lookup of location. We can actually remove this else. I think. Just return what we've got. Okay, so we just have to do GL lookup. Yep, Pat using SDL mixer TTF image for his own game. Probably should just implement my own features. Yeah, I mean, that was another part of this little project was, what can I do myself? Like, how hard is it really to implement some of this stuff? Turns out some of it's a big pain in the neck. Like, actually, decent text layout is shockingly painful. Until you've done it once, right? Then it's like, okay, I know what really goes into this. I hate shaping binders with additional libraries. Yes. In fact, so I'm statically linking everything on this project. And I handed the executable to my son. He put it on his laptop, and it's like, oh, you need this other library. I'm like, screw you. I said statically link it. So I'm probably, towards the end, going to have to get rid of the glibc and implement my own memcopy and stir methods. Yeah. It's going to make me mad. Yeah, no, libc, it's become a problem. It didn't used to be a thing when I was a kid. Like, you just write code, put it on the computer, and it would go. All these dependencies are killing me. Oh well, that's just me probably being old and curmudgeonly. I think it's justified though. So I have old code that did this. So let's see here. Ooh, let's see here. OpenGL look up uniform location. Get uniform location. So let's grab this OpenGL ES3 reference pages. That's probably what I want. Okay, so we need the program And the name, oh, name. So I actually have to pass in more than I want, really. Okay, all right. Well, I mean, I know how you get there, right? Like libc has a lot of optimizations and things that people have built in over the years that are architecture specific and blah blah blah. But like memcopy itself is not that hard. If you're willing to accept a teeny tiny performance hit, just write it yourself. Anyway, what do you do? Okay, so get uniform ID location, asset uniform ID. I probably need to pass in those. The uniform ID, I need the uniform names. The uniform names we're giving out are bad. Or I need uniform labels as well. I think that's probably the better answer. Uniform names. Uniform names. Uniform names. Let's get uniform names and labels. All right. Name for label. Name is fine. Uniform names. Just gonna copy all of this. Labels. Oops. Except instead of outputting this, do that. That's basically the only difference. Is that true? I think I want to do this. I want to be a little more explicit, a little easier to trace in my own code. 1, 2, 3. Just S. S. Okay. Uniform name. I don't want to be stuck here. Uniform ID name and label. Which this error shader uniform is invalid. ID. That's fine. Except uniform names. I want this chunk swapped out for this chunk. I want the names to be the short one. Okay. Which brings us back to get us here. Location. There we are. All right, so what we're looking at is, for those who want to follow along at home, we're looking at the GL get uniform location function. We need to pass in a handle to our program. So the compile, you pass these two shader code to the GPU, and it compiled it, and it gives you back a number that says, here's where we've put this program. So you have to pass that one in, and then we need the main name, which is why I just went through what I just went through. So we do have to pass in the shader. So let's see, let's take a look at our shader. What do I have in there? Depends once I've looked at it. I have the render ID, so basically the OpenGL ID. ID. Let's just get it. GL ID program. Sure. Actually, we don't need to do that. What am I saying? Wherever we do, but we do need, let's see here, this is int program. Assert that program is greater than or equal to 0. Okay. So int program. Okay. Okay. Cranking away. So our shader warehouse should look get uniform ID location. Okay. This log error is not, oops, not beautiful. That looks less terrible. We should probably do that. And that's not a new line. Okay, so we have a little bit of work to do that still. I'm going to pause briefly for a restroom break. Should not take long. Then we'll get right back to finishing this task here. Just a moment. So yeah, if you're interested in not writing lots of glue code, I have a Discord server if you want to get notified when I go online. Feel free to jump in there. It's not the most active Discord server. Won't spam you, but just a daily reminder when I'm streaming. Give a follow, like, etc., whatever, all the jazz. I do upload all of my videos to YouTube and Rumble. I also have a Twitter if you want to get notifications there instead. So, back to where we're going. Here we are. So, that needs a return. And then we need to break that log message. It's just too darn long. Location. Here we are. Like I said, there's this code snippet piece I need to get integrated into my asset pipeline. I really am missing it right now. The more I have to work in these chunks, the less I like it. Okay, so let's see. Pretty sure that's in the program. I'm gonna pass in the get uniform name, ID name, given the ID. And I usually wrap these in something. What's it called? Swords, OpenGL helper. I wrap them in GL call. Except this one actually returns the thing, which I think is why I didn't have this one wrapped. Is that true? Okay. I need to go look at what I did back in the day. Status. Get stash. Go back to our journal. Remove shader locations. That was in 0821. Get log dash in, I don't know, 50 log. Looking for August 21st. Wow, that wasn't far enough. We go to like this one. To be able to see GL get uniform location, exclude my dependencies. GL call result equals. Okay, so that was the correct thing. Oops. Okay, well, git checkout master git stash off. Then we come in here, GL call. Okay. GL call will just fail. I don't think there's a way. Let's see here. Get uniform location. Returns an integer, blah blah blah. The function returns -1, so I don't have to explicitly do anything. Perfect. So basically, it will always assign this to -1 if it fails, and will still return the -1, but it will never re-look it up because of that. We look it up once, we fail, we get an error message, and it just continues to fail silently every frame after that. Okay, I think that's it. I really do. Let me just return it. Okay. So we could actually shrink our code a little bit. This is not equal to that. If it's not -1, look it up and return it. This error message is way too long. And poorly indented. 1, 2, 3, 4. Okay, now this one needs 2 class labels. Yeah, this code snippet tool I wrote up, I'm really missing it right now. Gonna make this all much cleaner. Oh, how sad. Okay. No, we're gonna blow away shader warehouse. Whatever changes we made. Oh, that's all right. We're gonna cd tools. What? Where are we? Okay, cd tools bin / embed shaders. Okay, no, no, not exe. Cd dot. Not sure that did what I thought it was going to be. Is that running? Seg fault. No seg fault. I don't believe in seg fault. Oh, back tree. Oh, okay. Embed shaders line 75. Okay, great. It's just working. A length of 4, capacity of 4. We'll give it a lambda full of stuff. 278. We should add a thing to it. Permission denied. I will not be denied my permission. I will execute this build. Don't stop me. There it is. Now shader warehouse. Reload. Oh, it wants to line it up there, does it? This if could be simplified a bit. So if our shader lookup is less than 0, it means either we've not looked it up or we have looked it up and failed. So this is the I have not looked it up check. Then we call this. Then regardless, we return something. So, okay. So my layout, once we go line here, which I'm not as big a fan of, but whatever. Oh, come on. Okay. Here we go. Okay. So here's the question. Are we brave enough to try this? The way that the shader binds these. So let's go back to shader. If we are going to bind a particular thing, like a pair of floats, right? Uniform location. We have hard-coded in our uniform locations. So that's going to change. Let's just see what happens when we compile our main project. So dash k clean and debug. I assume that we have other errors to work through. But I think the shader asset pipeline side of things is just about done. And on the other side, I don't think we're far off. I did fat finger something apparently. Shader, geobit shader. IV. Okay, so the IV does have to be there. I forgot about that. Okay. What else failed? Okay, so these are no longer things. So everywhere we see shader set uniform, and I have this integer, this location that was basically computed, was pre-computed. That's going to go away. We're going to look it up now. We can actually hide it inside of these set functions, which is, I think, the right thing to do. I think so. And then these don't actually even change, just these functions. Okay. So in shader, we're just going to rename all these to shader warehouse uniform ID uniform. That's part one. Part two, we need to give a uniform location. Int uniform location equals shader warehouse get uniform I had a function to this, didn't I? Get uniform ID location. I guess. Uniform if uniform location is greater than or equal to 0, then do things. That's basically the pattern we're going to end up doing here. So like I said, really not that bad. These were integers before, now it's all typed and checked. Get uniform ID location. So we need the asset. No, we need int. Oh, come on. Oh, also, that's a good question. There it is, int program. The program, which is m underscore, I already forgot what I called it. M underscore renderer ID. I need the asset type. Did I keep the asset type around? Yeah. Vertex asset and that. Uniform with this. 1, 2, 3, 4, 5. There we go. There. Now we're passing around 3 integers. There's no dictionary lookup, and we have uniform locations for every uniform location in every shader that we have. Now, in a modern system, of course, you're probably going to create shaders on the fly, depending on what the user is doing and what levels they're in and what hardware and things are enabled. And so being able to specify your own uniform location would be amazing, but I really don't want to hit a hash function even when I'm failing a uniform lookup. So this should just about fix everything we need, maybe? Question mark? Okay. We just have to rescope those a little bit. This looks the same. For batch text. Yeah, so we just have to rescope those and okay. We missed a closing bracket there. Probably means we missed it for the count as well. Okay, friends, square bracket, done. That is fair. So that has to be a cast. So in here. Let's have a hanging white space. How dare they? Okay, now. Static cast 2. Uniform uniform ID. The whole thing. Okay, what else? Oh, that makes sense. We left this thing, this thingling. All right. This is why we do an asset pipeline. We can re-embed. Oh no! What? Oh. All of our assets in a single make call if we do it from the right directory. Which is how we normally do it. Usually our interactions with our asset pipeline is add resource to file and then rebuild. Okay, so those are all expected errors right now. And those are unfortunate errors right there. Oh, okay. Yes, I realized there were errors. I'd like to fix the ones in Shader Warehouse before I worry about the expected ones. Yeah, just about as I suspected. This one also missed square bracket. Key. Key. This is the uniform labels, which we just fixed in theory. A uniform, typo. This only occurs in one place. Uniform. Okay, what else? Shader Warehouse. Oh. Okay, so go to Shader Warehouse. Oh. All right. Okay, we're just running our way through the compiler. Log was not declared. Oh, good heavens. How do we not have a log included here? Okay. We fixed a bunch of stuff. Let's rerun our compilation. See what's left. Okay. Expected, expected, expected. Okay. Macro extends to multiple get uniform ID location GL call. This one does need a curly brace. Shoot. Alright, fine. We'll just put curly braces all the way down. Just because we can. Okay. Shader has 118. Okay. Well, clearly. Uniform names. Should have outputted one. Here. Uniform location maybe. It does return something either. Okay, so I need to put this. Turn -1. All right. Get through those and go crank through the expected errors. It'd be wonderful. This is always the part of the project where people's enthusiasm for the project starts to wane. I do keep a few fun tidbits for the very end, but those are like optimization types tasks that you should do towards the end anyways. Okay, so those are the expected errors. It does not like my choice of numbers. Fine. What was it? Negative some big number. Oh, it's not supposed to be 4. It's supposed to be like -2 something. That one. I'll just make it -2. I don't care. Just make this a thing. Good enough. You know what? We're not doing that. We're doing -666. There we go. Now it'll stand out. We'll look at that number and be like, oh yeah, that's the thing we can search for in our code. Yes. I'd been delaying this particular cleanup for a little while. And in fact, the next one too. Gotta get them features done. If you've got things working, move on. You just have to be very careful about noting what you've accepted as technical debt. Okay, so no outputs I don't expect yet. I expect all those. That's why I keep a journal so I know what I've worked on, and then I have a to-do list, which are the things I need to work on. I think that's working out pretty well for me. Okay, so literally just the errors I expect. Let's go crank through those. Texture quad 119, 120. Oh, good heavens. Texture quad 119 is where we are setting these, and we just need to hand it uniform ID. Do that twice. That's basically it. These are the two for texture quad. Quad batch has the same issue. Texture quad batch. Set. 2 of them again. 1, 2. Okay. Color quad MVP, color quad clipping, clipping MVP, quad viewport clipping. I think that's that. And then text. Whoops. Whoa, no, don't do that. Okay. 1, 2, 3, 4, 5, 6. I think that's it. Compile. Do not need to regenerate all of our assets, so it should not take quite as long. These should not yield errors. So the question is, does it all run at runtime? Oh. There's our first error. What? I really missed one. Yeesh. Okay. We do not need to do it clean right now. We've got a nice clean build except for that one in color quad batch. Boom. Done. Now we see if we can run it. All right. Source, build, debug. We haven't actually run a new build today yet because of all this refactoring. Here we go. Please don't die. Nothing shows up. And there are no errors. So that's unfortunate. Well, darn. I was hoping it would just work on the first try. Okay. Get, what's here? Location. I suppose we should trace in here. So let's go to our, let's see here, line 55. So we're going to do breakpoint in shader warehouse.cpp at line 55. Run. Okay. Hit uniform location. Program is 7. Find asset vertex texture batch. Sure. Our uniform ID texture batch textures. Okay. That one should be fine. Next, print index 2. Is that true? Shader warehouse.hpp. This is the text batch textures. That is not 2. If my, oh no, the index is different. Okay, yeah, that's fine. Next, print uniform index is 3. That I agree with. Yes, and the texture batch vertex is 2. I agree with that. Okay. Next, we print the start index, which is 2. Texture batch. Print count, also 2. Next, I agree. Print underscore uniform locations at uniform index is negative, so we go next. It is not equal to -1, so it should do this thing. Which returned a -1, but did not print an error. Okay, I don't suppose program hasn't changed. So this may be returning the wrong thing. Okay. Go to our shader warehouse. Temp. Although get uniform ID name. Should look this up in uniform names. And I said this was, what did I say it was? Texture, text batch textures. So text batch textures. Should return textures. Is that a thing in my, let's see, text texture batch textures. Oh, U underscore. I would prefix all my uniforms with U underscore. That's probably the issue right there. So where do we output names? So let's see. Embed shaders. Names. Names equals all of this. U underscore. So we build target tools embed shaders. CD into tools bin / embed shaders. Shader warehouse. Okay. Reload names. There we go. Now we have a U underscore. Perfect. It means now we can just debug. I don't think I need to clean it. I don't think we did anything that would require a clean. There we go. Hey, our renderer is back online. Yes. Hooray. Okay, and now to test, let's go sprint mode, play, and our frames per second looks fine to me. Toads, Ultra, Demon, Ace, Rhino. So for those who are joining for the first time, this is a word deduction game. People say it's similar to Wordle, but actually I'm copying off of a game from way back in the day before Wordle was a thing. Ultra Demon. So I know that C, H, I, P, and S are out, which means these are in, those are out, T or A, therefore U is out, and L is out. A is in, therefore no T. The main difference is we don't get positional information. I did not have to type that word. BY. Roan. Oh, really? Yanks. Oh, it's, well, no, it's not K. You know, it has to be B or Y. Since it has to be Y, it can't be B. if I didn't have streamer brain, it would probably pop out to me faster. Rayon, there we go. And then you get less guesses. This is sprint mode, so it's timed to 6 words. Marathon mode, you just guess as many words in a row as possible. Golf mode, you guess 9 words, but the least number of guesses. Time is not a factor. So, hey, all of our rendering is working. That means we're done. Not bad. Traves, time for bed. Thanks for dropping in. You get some rest, and yeah, we'll see you tomorrow. Okay, journal. We did it. That was not too shabby. Shader uniforms are now looked up once per shader program. No more extensions needed. Just good old OpenGL 3.3. Alright, we're done with that. So let's save our git status. Git add everything. Git commit -m. Shaders no longer use extensions. Also, no string dictionary lookups. Hooray. That one's been a long time in the queue. Okay, that took us 3 hours. Okay. Yep, see you tomorrow. Now, the next thing in our technical debt was our screen space scaling calculations. Let's go take a look at a run. If we go to settings, right now you can't see it, so maybe I need to change an OBS setting real quick. If I go to full screen, go to, let's see here. Let's do this. Let's dump that. Let's move this guy onto the same screen so I can see what I'm doing. Okay. You can see how big that is at 1024 by 768. If I resize it, it has to recompute button sizes, text sizes, label, font sizes, right? All that stuff has to be recomputed. So there's like a layout engine, which when you first load a scene, it says, how big is my render space? And then it computes all these sizes. However, we just kind of built it organically as we went. And so one of the technical debt things we've been dealing with is each scene has its own copy of a lot of the same code. So we are going to, first of all, move all of the common useful pieces into, I think, renderer. So it's useful anywhere. I think that's step 1. Step 2 might be that we come up with common sizes, like font sizes and things for all the scenes. But first of all, let's move all the calculation pieces into a central location. And I think the correct location is the renderer. We do things based on like a reference size, like some of the scenes are laid out relative to a 1024 by 768 and then get scaled up. Other ones we've scaled 1920 by 1440, and so anything else gets scaled down, so we're going to unify all of that. So this is a nice cleanup. This should reduce our line count quite a bit. Maybe not even quite a bit, but it should make me feel better about life, which is really the important thing, right? So, let's get back to ye old code and get into this. Do layout. I've basically put all this junk inside of the do layout function of each scene. And the setting scene is special because it has an old resolution and a new resolution. Any other scene, when you load it, we just need that one resolution. So this is all special custom stuff. But you can see that reference width, reference height, and then we scale things up in this case. The renderer already has frame width and frame height, so I don't need to restore that. But we will have a reference width and height in renderer. And then right now we're using these pound defines to scale with respect to height and scale with respect to width. Because you can't just scale things willy-nilly that way. So that needs to move. Then this code will just basically be calls to whatever we implement in renderer that does this math. Does that make sense? Hopefully that's clear enough. Because it's right now it's inconsistent. It's copy paste jobs everywhere. Let's get stuck into the problem. So I need a static const. Let's see, what is that? A reference width. And height. And that will be, I think I want to go with the large one. So I think I want to do it 1920 by 1440. And yes, I did choose all of this these sizes very carefully, so that the aspect ratio would always remain the same and I would not have to do any more recalculation on that front. So there's that. Then we need static. So deep down in my to-do list, I have tons and tons of technical things I would like to fix and change. One of them is, oh, I didn't note it? Okay, fine. Tech debt, change static classes to namespaces. Just a thing I've started changing over. So I don't use singletons. I have been using pure static classes for the purpose, but I think that just changing everything down to a namespace in a compilation unit is good enough. So that's the thing I'll get around to eventually, because the namespace is already static, so it just saves all the typing, makes it easier to read. Other reasons, no vtable, etc., etc. So we want static double scale width. Scale height. Set frame size. There it is. Return a thing. I'm going to steal that from the settings scene. Which you can see we already have the value for. Renderer test underscore frame width times our value. We don't have to do weird macro things here anymore. Divided by renderer reference. I forgot what I called it already. I'm that smart. Screen width. So scene settings. There we go. And it's just frame width times value divided by reference value. So there's no actual order of operations that has to be handled here. Frame height. Okay, that's most of this junk just gone. And not gonna lie, an awful lot of these values, I don't know what to do with. Also, this scene was scaled relative to 1024, which means these values are not going to be the same. They need to be scaled relative to something else. These need to be different. Basically, I need to say we're at 1920 by 1440. The scale versus width shouldn't change anything. It should be a 1-to-1. Well, right now this is scaled 1-to-1 at 1024 by 768. So I'm going to myself a note. 1024 by 768 needs to be transformed to 1920 by 1440. Right? 1920, 1440. Okay. I remember how calc works well enough to do this, or no, let's just do it. Let's just do it the hard way. Let's search for scale versus width. Renderer scale. Only I remember what it was called. Scale W. Oh. Okay, so let's try that again. Search for scale versus W, parentheses. Renderer scale W. Search for the closing parentheses, copy that. Now, at the end of the line, we're going to say we have 250, whatever this was, divided by now this is with 1024 times 1920 UXE parentheses close delete end of the line, search backward for this thing. And F4. Okay, so in theory, this 200 should scale up by not quite 2. Okay, and then scale versus height is going to be very similar. So we go to edit our macro, renderer, delete those. Space backslash got deleted. No, it's not 1024. It is 768. It's not 1920. It is 1440. There we go. Looking for scale versus height. Let's see how it works. So 50 should jump not quite double. The fonts are all scaled with respect to height for some reason. Okay, so let's just see how it looks. Okay, fine. Frame W. Renderer. Frame width. Oof, that's a terrible name, isn't it? One-third screen width each to 1/4 screen width. Two-thirds screen width to 3/4 screen width. Okay. Oh, frame height shows again. Render. Frame height. My children don't always think. Okay, so go to settings. Mostly that looks okay. Looks fine. Okay, I guess you can't see that, can you? Let's see, where's the screen scene? There we go. Okay, so now if I change screen sizes, everything rescales and doesn't look that bad in terms of this scene. So I think this one's done? Question mark? Well, done. Done is an interesting word because if you look at all the values we just did, where it says where we use, like, these are just ugly numbers, right? So how much do we round them off, right? 95, 20, 275 times 5, 470, 9375. Let's just make it 10. Spin box 115, 140. Oops, was that the same exact number? 187.5, 187.5, yeah. 190, 187.5 to 190.0 just for consistency. Okay, where else? 6045, that's all fine. Let's make this 132. Okay. So how bad did we mess up all of our layout here? Settings. So let's do the old song and dance here again. I don't see anything terrible here. One thing I do want to do is not truncate to integers. So everywhere we did this, we got an int. Mostly it, I think. So rectangles do handle double precision float, so not a problem. So we got settings about okay. Boom. I don't see any major layout issues. I think we're good. Cool. All right, so that's setting scene. So let's go to main menus. That's one we see regularly. Do layout. We don't need any of this anymore. And we should be able to just run this function here. Things will magically happen. Yeah. Auto indent misaligned things. Okay. I think F1. Oh, F1, F4. Yes. Whoops. What happened there? No. Let's go to F2. Now I need to know keyboard shortening your Emacs. Create new macro from current macro. Please let me just make a copy of it. Start defining, stop defining, execute. Yes, yes, yes. Calling a keyboard macro, query user. Yes, I did know that once. Prompting during keyboard macro execution. One key macros. Okay, so here's what we're gonna do. We're going to F5. Copying this, killing it. Now we're gonna record a new macro, which does nothing, but then we're gonna edit it. We're gonna paste all this. We're going to change it to scale versus width. Then we're going to find 768 and change it to 1440. No, 1024. And 1920. I don't think anything else needs to change. Okay. F4. Oh, okay. I guess that was that. Renderer. It's frame W, right? Yeah. Renderer. Frame W. Frame width. Okay, wow, that was way easier than it should have been. And then ints to doubles everywhere. Nope, yes. Nope, nope. Yes, 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 no. Okay. Yeah, the main menu scene is not very complicated now. It feels like it did not scale the width the way I wanted. Scale versus width. This one as well. Probably because I had not recorded the correct macro yet. F4, that's better, and F4, yeah. That feels better. Okay, so then I'm somewhat curious if like I should get common values between these, like this big button width. It's very similar. 70. Big button height. 95. 20. See, these are starting to feel like very familiar numbers. 375. 75, we just went to 10. I think 75, if I'm not mistaken, just went to 190. Then big button font size. Big button font size. Small button font size. So 45, 32, and 60. Scale. Okay. All right. I think all else being equal, main menu scene is probably laid out about as good as it's going to get. Times like this when I start wondering if I should have like a style, reference images, reference sizes, I don't know. Okay, main menu. So let's bring this over. Show the screen. Okay. So this doesn't look any worse than before. In fact, well, we need to yeah, well, that's fine. So settings, we go huge, back to main menu. That does not look terrible. Settings in the middle, back to main menu, still looks fine. And back. Okay, so I think main menu's done. Very exciting, these technical debt issues that you let build up over over time, huh? Let's open up the about scene. That should not be a hard one to do either. This one is also 1024 by 768. There are places where we did not use that as our reference width and height, so. Okay, so we go F4. Okay. Then we go to our previous macro and scale the height. Big label, 140 is fine, 95, which we've used before in other places, 470, 95, and 20. Big font, small font. I guess that's it. So about scene. Oh, and then ints to, so we're gonna have ints to double. And we probably have a frame width or something here. Frame. Okay. What's going on about here? Internal static void. Well, we are doing refactoring tasks. We are feature complete on the game. So we're hitting all the technical debt we had accumulated before we recently got rid of an OpenGL extension to keep ourselves on OpenGL 3.3 strict. Right now we are centralizing our screen sizing functions to one location. So yeah, bit of refactoring today. Not the most exciting, but if we get it done, we have a couple of optional features we may add to the game. And you, what's going on with you? How are the VMs behaving? Okay, we're just gonna start replacing. This is garbage. Okay. With renderer frame height. We should have probably done this a lot earlier. Renderer frame width. VMs are in fact virtualizing. They are the most virtual of all virtual machines. They are paragons of virtualness. Virtualocity. Sounds too much like velocity. Yeah, I don't know. That's a tough one. I'm gonna have to think about how that would conjugate out. I have nested VMs too. That does seem a little excessive. VMs with VMs, it's just a little perverse. Writer, hello, welcome. How's the let's see here. So you had the non-technical interview. Did you get called back for a technical interview yet? Oh, well, we don't have to capture that then, do we? Or that. Perfect. Well, for my use case, it makes sense. The one that has the nested VMs isn't. I'm using VMware on it for a course. Okay, yeah. Nope, waiting. Yeah, FitWriter. I know what you mean. I've thrown my old resume out to a couple of spots, and they it's really not a very good market for jobs that I can tell. I mean, we're not in the same boat. Like, we're not competing for the same job, you and I. But if entry level devs are getting ghosted and senior level devs are getting ghosted, like, that's just not a good market. It makes me sad. So this was the about scene, which we should bring over here and show the screen so you can see the scaling. There we go. So that's teeny tiny. Blah, blah, blah. Okay, so the size is fine. If we make it huge normicus, about, yeah, that's still readable. Or, I mean, the scale looks about the same. Okay. Yeah, nothing seems broken per se. So if we go to mid-size, yeah, that scaling seems fine. Okay, good. Not that one. Even McDonald's jobs are super. That's what I want to pick. There we go. Yeah, I'll probably go work at McDonald's after graduation if I couldn't get any job. Yep. I mean, we've all done it, right? That's you take the job you can to pay your bills. I feel really bad for computer science grads nowadays. Yeah, no joke. No joke. So let's see. When did I graduated? 2008. Well, I graduated. I guess I did graduate before the economic crash of 2008. So I got hired pretty easily out of college. But like I said, that was just before the economic crash of 2008. And I feel like this economy is worse than that one was. Even McDonald's jobs are super competitive. Yep. I won't do the long version of the rant. Oh, come on. We love walls of text. But having done computer science and done a real dev job, y'all are getting scammed. Yes, they are. I feel a little bit scammed by my own computer science degree. I do not think it properly prepared me for real development work. It felt more like they were trying to crank out more computer science academics, not teach you real world skills. And I think that it's probably gotten worse since I was in there. I had to insist to be put on the previous catalog at my college so that I would have to take the classes that were useful and not like software engineering where you did UML diagrams. Yeah, I don't know what to tell new grads. It's a little bit depressing. A little bit depressing, not gonna lie. Okay, so let's see here. We've done main menu, settings, and about. So we need to do high scores, sandbox. I don't remember how much is in sandbox anymore. Let's do high scores. That would at least make sense. Okay, so this one also has that same scaling. Let's do that. Let's do that. And then we're just going to run our macro that we already wrote. Or what? Oh. Uh-oh. Uh-oh. Wait just a minute. Why did that not work? I don't feel like that is fundamentally different from what I've been doing. Did I accidentally change a thing? Huh. Well, that's odd. That macro worked just fine right here, but not here. Why not? Okay. Search forward for scale versus height. Parentheses. Return to accept this search. We go backwards 3 words. Type in renderer 2 colons. Lowercase the scale. Kill word forward to get rid of the underscore versus. Delete to get rid of the last underscore. Forward 2 characters. So this is skip the parentheses. Mark. So we can go meta forward to go forward a word, then backward word. Let's hear. Meta B, forward word, backward word. Mark. Search forward or the closing parentheses. Go backwards for it. Kill ring save. Go to the end of the line, space, parentheses. Yank out our value. You know what? Let's just do this, space, yank, space. Forward slash space, value, space. Why are we going forward 2 words? $768. Oh, this is getting messy, isn't it? You know, let's not save this macro. Let's just try recording a new macro. Let's just do this. Search for scale versus height parentheses. Multiply the division of my value and 1440 multiply by 768.0, which is the exact backwards of what I want. Right, so let's cancel that. Okay, record a macro, search for scale versus height. Lowercase, delete. Okay. I feel like this one should not be so hard, and I'm not sure why it suddenly started failing. I assume I have a stray keystroke somewhere ended up in there. Oh, macros, let's see here. I think the fact that basically no computer science programs, with the exception of Harvard's, are, as of like this year, teaches Git, speaks volumes for the quality or the quantity of the coursework. Yeah. I think 3 years of it, I started my first programming class 2 years in. Yeah, that's just broken. That's terrible. I have a career fair at my uni on the 19th. Career fair is a good place. People that go there want entry-level workers, and no. Yeah, so my college career, I deliberately took every project-based programming class I could find. It was pretty easy to spot which computer science professors had not written code in 20 years or ever. Like, they were just academics because they sucked at what they taught. Like, we had our systems programming teacher arguing with a student that the TCP protocol does not operate at the TCP layer of the OSI model, which blew all of our minds. So I avoided those classes. But I did have some professors that actually had got industry experience, and the ones that I liked, I took every one of their classes. Yeah, I know. What the heck? So the student brought the Cisco manual, and he's like, "Here, this is what the Cisco manual says." The next day, the teacher brought his book, and it said, basically, the lines between protocol layers are a little bit blurry sometimes. It's like, we all just, like, it was so stupid. It was terrible. But then, like I said, they were trying to move to this new catalog, and my advisor was like, "No, you should go on to the new one, the new catalog." And I was like, "Hold on, the new catalog wants me to take software design, software engineering 1 and 2, which is literally drawing UML diagrams, right?" And I was like, "No, I want to be on the old catalog." And he's like, "Well, that'll require that you take compilers. That's a hard class." And then he looked at my GPA. He was like, "Oh, yeah, you'll be fine." I was like, "Yeah, you learn so much more from a compilers class than you ever learn from a software engineering class." So yeah, the whole thing was just a mess. And that, like I said, it was only getting worse as I was in there. So I hate to think the new people, what they're getting. I had a few of them. I mean, technically the entire OSI model is made up BS anyway, and nothing really matters. Technically, yes, but if you're arguing with a student at that level, like, yeah, that teacher was, yeah, special. He was special. He was not my least favorite professor, though. My least favorite professor taught algorithms, and he hadn't taught a class in 7 years. Lots of the profs go, lots of mathy stuff, unnecessarily complex discrete math stuff instead of practical stuff. Well, I'm kind of a split mind because to some degree I really enjoy the unnecessary mathy, complex discrete math stuff. Like I'm not all hardcore about it, but I do enjoy it. if I have someone who can explain it. When the teacher can't understand what they're explaining, it's just, oh, because they've never written a line of real code in their life. Like within the first, 5 years of my career, I bet I wrote more code than 75% of my professors had in their whole life. The Cisco manual, the Cisco is kind of the big name in networking. If you, yeah, and more so back then, the Cisco the certifications back then meant something. They've all been gamed out now, though. I don't think they're useful. But back then, data structures class you should do in the context of writing a database, because it's one of those things where one is going to know what the F data structures are, or even why they matter unless you're implementing a database. Yeah. Yeah, I mean, yeah, it's a balancing act, right? There are tools and times to use these data structures, but like they come out, all they know is a handful of fancy schmancy data structures and not when or why to apply them. So you have people creating dictionaries. It's like, why don't you just make it an array and look it up by index? Why are we doing this? I don't know. But you know, I think personally the programming might be better taught as almost like an apprentice journeyman master model. Maybe you take some classes like an electrician, right? They have to take some classes, classroom classes, but then the rest of it is I'm working under somebody more experienced than me, which means not only do they learn the electrician stuff, they also learn how to run a business and how to interact with customers, and because there's somebody there teaching them all aspects of the job, not just here's how you strip a wire and here's how you use a wire nut, right? I think programming might benefit greatly from that model as well. I don't know. Cisco CCNA is any day better than taking a networking course out of uni. Oh yeah, 100%, 100%. Because they get paid based on how well they train you to take care of their stuff. If it becomes harder to maintain their hardware and their software than someone else's, they'll get kicked to the side. If a college turns out a class that's garbage, there are no repercussions. So yeah. Okay, so what was I even doing? I was trying to re-record a macro here. So we're searching for scale. Scale versus height. Renderer scale height. Delete. Multiply the division of our thing over our reference height times our new reference height, UXE, search backwards for this thing, search backwards twice for that thing, delete, delete. Okay. Okay, those are working again. I don't like that I had to rewrite that macro, but that's part of the game, I guess. All my font sizes. Okay. Then in F5, we're going to copy everything. Create a useless macro that does basically nothing. Oops. F4. Now, we're going to paste all that junk. We're going to change it to width. Change it from this number to 1024. Instead of 1440, we're going to 1920. Oh, that was way better. That's basically it. Okay. And then replace frame width with this. Replace frame height with this. Then ints become doubles within this context. Nope, not that one. Nope, nope, not indices. Font sizes that we can do. Nope, 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 nope. Okay. Oh, okay. And then to round things off, 0, 95, 46. That's kind of. I guess we're going to 45, 470, 95, 280, 75 is fine, 20, 10, 750 is fine, 470, 280, 75 is fine. Ooh, 55, I guess. 100. 75 is fine. 45. 41. 40, I guess. Ooh, 22.5. Let's go to 20. Alright. See how the high scores look. Oh. Mailbox new. What are you coding? New high score? We are coding a game with no game engine. And we've kind of got all the main features done. We are exploring the we're doing some cleanup, technical debt, bugs, loose ends, items for a couple of days, and then we'll go if we're quick enough about that, we will go add a couple of bonus features. So right now what we're refactoring is the scaling code. So let's, in theory, that worked. So let me change the way we display things a little bit so you can see what I'm talking about, because we're testing this anyways. Good timing. So here's my window size. If we go to settings, we make it nice and small. Go to high scores. I don't have any high scores in right now. Okay, but everything's more or less there. We could, let's go to play. Let's make a quick high score. Toads, demon, lace, rhino, cloud lines. So that's 5 letters in the first 3 words. The word chips does not exist in here. Lace, rhino, proud lines. Therefore, RO is in, and M is in, not D, T, or A. Therefore, U has to be in, and A has to be in, and T has to be out. That is a lot of vowels. Huh, I'm not sure I know what that word is. What is that word? Bonus points. You get extra credit if you know what that word is. Anyways, doesn't matter. We just need a high score. Amour. Oh, that's French though. Why would that be allowed? Okay, then we have to fail real quick. If we surrender, it doesn't count as high score. So we're gonna fill up this lino, which rhinos, dump, cloud lines, match, ED, logs, jacks, waxed, inked, human. Oh, we failed. Shoot. We got our new high score. The dough. And now when we go to high scores, that text and button do look correct. So then we go to settings. We make it huge. Back to high scores. That scaled correctly. Everything looks like it's got reasonable spacings, font sizes. Oops, yeah, not that one. We go mid-size, high scores. Okay, yeah. So I think the scaling for that one is done as well. Mostly we're down to just the game scene itself. That needs to be refactored. So that's what we're doing. We're gonna do, yeah, clean up paths for a couple of days, add a couple features if we have the time. Then we're into polish, like doing actual art, not like crappy programmer art, hopefully. More sounds, clean up animations, all the little things to make it more useful and nice while I go about doing the business side of things. So that's where we're at, Mailbox New. Welcome to the chat. Let's see here. I guess now's a good time I need to plug my Discord channel. If you want notifications when I go online, that's where to go, or Twitter. I also post all my old videos on YouTube and Rumble, so check it out. Those settings have a lot of options. Were you adjusting the aspect ratio on that grid? No, so I was very careful. Very careful. So this is the first game in the city, in this little project I'm running, and I deliberately chose a very simple game. I deliberately limited myself to OpenGL 3.3 and nothing newer. And the screen sizes I picked are very deliberately all 4:3 aspect ratios, so I don't have to worry about aspect ratio at all. So, yeah, everything I could do to simplify, I did. Because, like, a lot of people are like, I'm going to start right off with my magnum opus game, right? Hello, Amazon Studio. How did that work out for them? So I'm going to start small, get some skills, build up some tools, go through the process once, build another game that's, again, relatively similar, simple. You know, another homage to an old, like, 90s or 80s game that I played. Maybe about Game 3, we'll actually crank out something new, interesting, innovative, something I wanted to work on more so. So that's kind of the plan. But yeah, no, aspect ratio was fixed. I did that on purpose. Okay, internal static void. I honestly think one of the main issues of computer science degrees specifically is that they don't actually teach anything that you're going to do in the real world. Yep. And I don't think they even teach to the level that they should be teaching to, 100%. Like, I think someone should be finishing a computer science degree knowing what a pointer is, yes, or knowing what a stack and heap is, yes, and what happens when you call malloc, and what a page is. Yes, I agree. I also think it's a tragedy that 99% of the time computer science degrees are forcing you to take a data structures class before you've even taken a programming course. Yes, 100%. In conclusion, where I work takes interns who usually struggles the most, computer science students. Who usually struggles the least, electrical engineering students. Yep, not surprising. Travis Vroman, how's it going? We're in the same boat with technical debt. I saw that on your Twitter the other day. You were doing some refactoring items. Yes, we're on the same boat. Welcome, welcome. Yeah, so let's see here. Where's my journal? Yeah, so I've been limiting myself to OpenGL 3.3 refactor tractor. Yes, indeed, honk the horn. I've limited myself to OpenGL 3.3. I did use an extension, so we just went through that today and removed the extension and rewired everything. It was for getting uniform locations. So that's done. And now our screen space calculations for laying out our UI was copy pasted, scattered all over, and not consistent. So we're moving all of that into a single place and being more consistent with that. A couple of days of this, refactor tractor, as you say. Then I think we'll add a couple of bonus features that I want to work on. Let's see, where's my to-do list? So hopefully we get to the TechNet all done by tomorrow, maybe. Then I want my... we have a time scale factor when we do a replay. And the time doesn't scale with... the sound doesn't scale with our time. So I have to cut it off early if you're playing it fast, replay. Then we might add some sprite sheet animations. So those are kind of two things we want to do after the TechNet's done. Nice, always feels good to finish the refactoring though. Yes, it does. This is kind of the place where a lot of people lose interest in their project though, but like this is the pre-polish phase, right? This is the setting everything up so that you can really work on the user experience. With that TechNet hanging over your head, it's just going to hang over your head. Yeah, so eventually we'll get around to reworking our art and yeah, better animations, better art, all that stuff is coming up. There's even elements we haven't done crappy programmer art on, which we need to do before we can upgrade to mediocre programmer art. I'm not an artist, so that's all right. We'll make it work. So we were just doing refactor. So where was I? And how is Kohi going? I've kind of been following on the Twitter and poking in at watching some old, not old, but watching recent streams a little bit in the background. How's your first game going? Do layout. All right. So we're gonna just use our little recorded keyboard macro to replace all of this bad code. Oh, did that actually work the way I thought it would? That's a good question. Wow, shockingly it did. That's as intended. Perfect. That was way better than I thought it was going to go. That did not. Okay, so we're going to go back to here. We'll come back to that one. Okay. I'm going to go back and record this macro. Not record, replay this macro. Is that correct? Scale versus height, 20, should roughly double. Okay, yeah, that's fine. Boom, boom, boom. We'll round these off later. It's going well, lots of rebuilding around assets and resources. Hoping to finish that soon. Got a small list of a few more features to add, then it's game time. Yes. You know, one of the hardest things about this game dev stuff is actually limiting your scope. Like, there are so many things that I want to build after this game is done, right? That I'm like, no, put it on the back burner. I can make this technically so much better, but I've got to get this game done. So yeah, I know what you mean. Just a couple more features. What if I improve this a little bit? It's dangerous. That's why you got to plan like 3 games. You're like, make a game, Then you fix the things you didn't get around to. Then you make another game. Then you fix the things you didn't get around to. By about the third time, you're like, yes, yeah, one more thing. Yeah, exactly. Yeah, you have to maintain a very dynamic to-do list, and priority also has to be very flexible. Like there are times when you're like, I really want to work on this, and you look at your list, like, no, it's got to move down the priority list. I'm afraid. Yeah, yeah. I figure three. Three is about the number where you're like, I've got it figured out. That's what I think. Eventually around here, we're gonna hit that scale. Okay, so we're gonna cheat. We're gonna cheat bigly. We're gonna break these out on our own lines so that my macro doesn't interact with the things around them. There we go. F2, F4, that's not right. Okay. Render scale versus width. Times divide by 150. This is by width, so 1024 and 1920. All right. Put it all back on the same line. That's the cheat button anyways. That's not even like that big of a deal, right? Scale versus height. No. This one. Scale versus height. So again, let's break this out on its own line so it doesn't have to put around it. Boom. I have a feeling there's going to be a lot of work I haven't thought of around release build packaging, etc. Yeah, so exactly. It's such a pain. So I have end of project tasks. Like this is where I kind of mix the business with like optimization stuff while I wait for Steam to get back to me. I'll be doing like size optimization stuff. But like executable icon for my program. I don't have one. I really want to get rid of this stupid library. I tell it statically linked, but it says I have to have this to distribute it. Just so yeah, I've got and never mind the things I don't know, like Steam developer integration. Like I don't know how to do that. I've not done it. So that's gonna be a learning experience. I can't estimate it. No idea how much work it's gonna be. Yeah, yeah. It's all yeah. So you throw it in your list, prioritize it. Nothing else you can do until you run into it. So well, cool. Sounds like we're in a very similar sort of area in terms of our progress. When I started streaming, I scoped this at about 3 to 6 months as a guess, and this is what, week 13, so I'm feature complete, cleanup, maybe a couple of bonus features, then polish phase for. So I think I'm well within my 6 months. So not a bad estimate. I plan on streaming as much as possible without doxing my Steam stuff, of course. Yeah, exactly. Yeah, I don't know what I'm gonna do about that. I assume they hand you like unique identifiers and things, or unique links that you have to reference. Connection information. I don't know. Yeah. Well, yeah. Could be fun. Could be fun. All right, scale versus width. Wait, where did my scale versus width go? This one? No good. What happened? Which macro? Okay, well, we're gonna cheat some more. We're gonna record a macro, which does nothing. We're gonna edit it, paste this one, just change the names. Width. It's not 768, it's 1024. It's not 1440, it's 1920. Boom. Okay, scale by, oh, okay. That's scale versus height. Oh, I think that was the last one. Hallelujah. Of that line. I think what I'll probably do when I register is record it offline and edit that stuff out. Yeah. I wonder if you can write, well, yeah, I don't know about what's involved in it. I guess you could write stubbing out all the code and put in dummy values and know that it's gonna fail online on stream. Then you just do the last bit of cleanup and plug in the right number or right link or whatever right string is offline. I don't know. That's a good question. Maybe you've got the right idea. Maybe just black box a recording. It's probably more efficient than trying to play games with all of that. Okay, so we've basically got that part done. Kind of round things off here. Since we scaled by a weird number, just gonna round things off to reasonable numbers. 75 seems reasonable here. If we don't like them, we can change them later. There we are. That looks like about a 55. 205. We may regret some of this later. Kind of doesn't matter. I need to redo all the work, all the art anyways. So aligning stuff in the game scene is less important to me right now. $280. Ooh, 5.625. That's not a bad number. 5 and 5/8. I don't hate it. Ooh, 63. Let's go 65. That should be plenty close enough for that number. 55. 75. 37.5 doesn't hurt my feelings. Okay. Last thing is we cast everything to integers even though we're working with doubles, so doubles are floats, like we might as well just make them use doubles. Why are we casting that from integer? That seems even worse. Okay. We do not need to change those. The step, yes. Index, no. Font sizes, oops. This must be old code. We'll have to come back to that in this. Oh, we don't have to come back to that in a second. We can do it now. Oh. Actually, scale versus height. We can use our macro to do this. It's easy. Okay. Now which macro did we have? Let's go with this one. Scale versus height. Perfect. 60, 45, 30. Those are all nice round numbers. Okay. A couple more items to clean up, and then we'll run the test. We're going to change out frame width for renderer frame width. And then frame height for renderer frame height. I think that's it for cleanup on that one. Pat, sent you the Wordle game I've been messing with. Let me know if it works. Yeah, so Travis, this is interesting. Pat does like AI programming just to see how bad it is. He's been making his own Wordle game using the AI. It's pretty funny. He sends me code snippets. It's pretty bad. Uses all the stdme, all that lovely C++ junk. Super fun. Most of my friends aren't on Windows. None of them can test it because none of them know how to program, just sysadmins. Oh yeah. Everybody that's been using Linux for like 15 years tells me he doesn't feel like installing development binaries. Oh yeah. Oh, that was the interpreter. Yeah, so he's also making a language interpreter with AI, and it's quite the adventure from what I've seen. Dub is not a type. Can you believe that? Who would say such things? Unfortunately, I'm doing most of this Wordle app with my own stupidity. Yeah. The AI has done a lot of the work, though. That's cool. Mostly we make fun of AI on this channel, but Pat still does his thing. How many places did that show up? Confused. Okay. So in theory, let's see. Let's put this over here. Hide this thing, and then we share this thing. And if we go to settings, we set it real teeny tiny, and we play the game. Okay, so it looks like we have a little bit of lineup issues here, but not too bad. We changed our Y offset a little bit. This all looks okay. These will all be replaced with graphics eventually. Someday, next few weeks, hopefully. So if we go like ink human, ooh, come on, take the inputs. R, I, E, and P are all in. L is out, so C is in. Price. Yay. Yeah, this needs a definite art overhaul, but this all seems to work okay. So if we type the same letter twice, okay. I'm happy with that layout. So let's go big mode and play again. Let's go back. Let's do this in sprint so we get the timer. Okay. Yep, that looks okay. And like I said, I don't care about the lining up in the bookshelf right now because we're going to redo the art and that's going to change all the layouts anyway. As long as it's within reasonable area, I'm fine with it. Doses, codes. I'm a programmer. Uh-oh. Maybe it's ed cosed? Soast? Uh-oh. Anyway, alignment looks fine. Everything's change our journal, our workbook. Okay. Layout looks fine. I think we're going to call that Here we are. I think we're gonna call that a good refactor on all the scenes. Sometimes I'll make the AI refactor its own garbage using specific programs, paradigms, and it does seem to work to an extent. Yeah. Well, like we talked about in the Discord, if you tell it it's wrong, it'll just agree with you. It's not smart enough to have a principled position, so. Exclude their dependencies. Okay, so button. New high score scene. Oh yeah, I forgot about that one. We have not done the sandbox. Oh, scene. Text edit tooltip. Okay. We still got a few items to go through that are. Yeah, the AI makes stuff up. Definitely. Alright, so we gotta do the new high score scene. Good old do layout. Let's just start with the int to double. Because why not? Good. Then we change frame width to render frame width. Same thing for frame height. Okay. Then run our macro, which is scaling versus height right now. Okay. Then we change macro to scale versus width. And of course, it fails. Why would it fail? That's not nice. In fact, that's not even. Hold on a second. I don't know if I have enough undo for this. What? Why are we scaling like that? That is. Oh, big label width. Okay, not button. Okay. Never mind. I'm okay with this. I remember why we did this. Which means we just have to redo all this work again. Frame width. Remember frame width. Int to double. Okay. That's just frame width, literally. I don't have to scale anything there. Okay. Okay, then scale versus height is this macro. And we search for things we want to. 112.5 is not a bad number. Over 70. 95. 20. 45. 45 is fine. 33, let's go 35. That's basically it. Well, as long as it compiles, I'm fine. I'm used to telling computers what to do as opposed to what not to do. Lol. Well, then clearly you don't use Windows. Every time I get a new Windows install, I have to go get shut up 10 and turn everything off. Everything. Oh my gosh. I don't like the default on for modern software design. It's taken me a couple of years of prompt engineering to learn how to talk to these models. This is the first year where I feel like the models at least have the amount of data that's required for some sort of decent output. Still idiotic. Yeah, Arch Linux, huh? Well, where did hold on. There was somebody in the chat. He does lots of like BSD virtual machines, internal static void. There he is. He's doing a class. He's got like nested VMs inside of VMs. I'll use Windows when I have to, though. Well, I figure it's solo dev. I'm targeting the most bang for my buck for my Steam game, right? So it's probably still Windows, I'm afraid. If I make a decent amount of money, I might port it to others, but yeah. Cross-platform with no engine, it's a bit of a chore. Haven't used Arch in probably 10 years. Yeah, I don't know. I've used like Octo, a Red Hat variant, Raspberry Pi, Ubuntu, Mint. I don't know. They all look very similar on the command line once you get going. My buddy just installed it a couple months ago. It's like one command. Yeah, isn't it terrible? This is supposed to be like gatekeeping. Like you have to have a certain amount of dedication just to get it installed. Okay, so let's see here. So we basically did that one. Sandbox scene. The scene in general. Not sure why that has any. Sandbox scene, I can kind of believe. Might need it. Okay. This one. Let me change out ints for doubles. Actually, let's do that. Oh, this is worse than I thought. Okay, F1, F4, F4, F4. I don't like that. I don't know why. I probably do. It's probably me hitting keys too fast and not hard enough. I think my keyboard's on its way out. A few more months. So in my case, OS stuff is all abstracted to a platform layer, which has been in for a long time. So I can dev stuff in Windows, Linux, or Mac OS if I want, which is handy. Yeah, for my first project, I didn't want to waste too much of my time on that platform layer abstraction, right? That's unfortunately pretty heavy lift. Like I'm just using the GLEW, GLFW as my layer between myself and the OS, and I don't do anything else OS related if I don't have to. Main dev environment is Linux. Test on 132. Every once in a while, it's still good and fine. Yep, 99% of the time it is. Yep. Then you touch the platform code and kiss it goodbye. It is a heavy lift. Yeah. Yeah. Well, I'm not sure when in my roadmap I plan on doing that layer. End of this game is definitely like clean up, do a lot of technical things that I want to do, but I'm not sure that platform layer abstractions fit in just yet. Not sure about that. I mean, it needs to happen eventually, for sure. Frame height layer. Okay. Just see if that compiles. Unbelievable, it still did it to me. Alright. Dub with double. Not sure why all these are aligned this way. I must have had a longer variable somewhere. Okay. Yeah, that's fair. I did that way as a challenge because 90% of the tutorials out there for this stuff always says we'll do other platforms later. That's fair. Yeah, no, I mean, it is one of those things where it's really easy to put off and put off and put off. Like, there's always something more fun to work on than platform layer abstractions. I cannot lie. It's one of those self-discipline things. When it's the right time, you gotta force yourself to actually do it. I am not there yet. For multiple reasons. Like, it's not a... Let's go 190, I guess. Sure. It's a very kickable cam, yeah. Well, I am not as far advanced as you yet, so. So sandbox scene. What's in scene? I don't remember scene doing much layout. Okay, so it's not. F2, F4. Okay, so that refactor is done. Oh, come on. Read. There we go. Finger all the way over. I need frame width to render frame width. Frame height to render frame height. Scale. Okay. Ints to doubles. 1, 2, 3. Those are all fine. And then for some reason, I have this other pound to find the scale based on frame height and reference heights, and why the heck? Why the heck would I do that? That just seems unnecessary. I don't need this frame height. I don't need this frame width. Reference. There we go. Okay, so that one I think might be done. Okay, that's a reasonable number. Reasonable number. Ooh. Okay. 10. 20. 85. That's a, yeah, just a height. That's not a big deal. 35. 35 seems reasonable. I'm okay with that. Okay. File. Yeah, don't blame anyone for not doing it early. It was a pain. Oh, I'll bet it was. Like, that's. But, I mean, that's kind of the point of this project, right? Is, well, in these kinds of projects, right? Is to peel back the layers. I just don't feel like I've peeled back enough layers to build that yet, right? But eventually, and this is different projects, different goals. Like on my compiler project, I want to get to the point where I don't, when we emit code, that we're emitting an actual binary. We're skipping over all the linker. Like I want to emit Intel x86 64 binary assembly. So, but that's all way down the road. Way down the road. Okay, so we should have gotten rid of most of them except for. Where is my rep? There it is. Button, text edit, and tooltip. We can get those done pretty quickly and then run it all in a quick test. So, tooltip. Oh, look, it's right here. Was that it? Two things. Get it down here. Oh, but these are not. These are referenced against my maximum height. So these actually need to not behave quite the same. Which means I have to remove this scaling. There we go. Okay. That's okay. 200 is fine. Oh, but this one. Let's just reload it. Oh, it didn't happen soon enough. Well, shoot. So this one was times divided by 56.25 over, this is height, 1024, 40. So this was a 40 pixel, and it is not scaled because we are because that reference height is our maximum height, which is what we're trying to be consistently referencing against. Do I change my macro, or do I just take win? Scale. Make a new macro. Search for scale versus whatever. Of okay. Scale versus regular. Just take that. Okay, so I did that. Where were we scale? Go double. Double. This is, yeah, one of the reasons this needs to be cleaned up. It's pretty inconsistent. Okay, so tooltip should be good. Button. Wait. Frame. No, okay, good. Okay, here we are also scaling against that stuff. So this macro should be fine. Odd. We're only using one thing. Oh, that makes sense. This is button. This is the bevel height. Everything else is managed by whoever's laying it out. Okay. Easy. Okay, so that's button. What was the next thing? Text edit, I think. Frame width scale. F4. or nothing else. Margin double. Okay, so just a test, check. Margin and cursor width are floats. Very consistent of me. You don't need the double precision probably, but it's fine. Let's just see how this all comes out in a full clean and build. And then we'll run it. And that may be our task for the day. That would be nice to have that refactor done. So our next refactor is more decision making. This one was, I just don't want it scattered everywhere and copy pasted, so. Okay. Old macro problems. Apparently can't type. Doodlebay. I don't even know what that means. Double. Paste that one. Margin 2x. Oh, because it wasn't. Okay. Okay. I can't stay too late today, folks. I've got a meeting at 6, and I've got to get my binder all put together for it. It's inconvenient, but that's the way life is. Okay, so those are all gone. Scale versus should all be gone. Freaking sandbox scene. I think it's all commented out stuff, but F1. Oh, not this again. F2. F1. F1. Where? This one? Is this one still work? No. Oh, I assumed, possibly erroneously. Okay, my reference heights are this one. Okay, so this is fine. Int 2 double. Nope. Sheesh, why is my pinky jumping out so early? Int double. There we go. Yes, 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 yes. No. Nope. Font size definitely needs to be scale. Okay. What else? Frame width. Render frame width. Oh, not using it. Frame height. Height. Okay. Scale versus width. I guess we cheat again. I don't like doing this, but for some reason there's something with that scale versus width. It just doesn't stick. So this is 1024. 1920. This code is all commented out, so I don't really feel like going through all that. Okay. So in our shell, we grep, and it's all gone. All right, one last clean and debug, and we'll run it and make sure it works. It had better work. Because we are finally consistent with where we are scaling our components and our screen size stuff. Getting closer in the seams and the main and last. Run it. Okay, settings. Okay. Cursor still looks okay. The cursor looks a little thin, but we can change that. But as far as scaling goes, that's not bad. Play. Our tooltip should, yep, be fine. Okay. I think we are done with this refactor. Screen scaling refactor is complete. All reference sizes are centralized. No more copy paste. Things look okay still. Okay. Save the work. Oh. Did we not commit that last change? Whoops. Are we? Are you kidding me? Oh. Okay, fine. Let me stage everything you can get and commit. Finish refactor of screen scaling. Done. So tomorrow, I've written some components which do not expose the child components. So like, for example, in the integer spin box, there's 2 buttons and a text edit. And in some cases where I've done this, I just expose the child element. Like, look, get the text edit element, and you can edit whatever you want about it, right? The color, the font, etc. In other cases, I just created delegates to those functions. I'm like, text edit dot set text color, and kept the text element itself hidden. And these two are decide which way I want to go and be consistent about it. So that's kind of tomorrow's tech debt. So I think that's going to wrap it up for today. Thanks for joining. Always happy to have you all here in my chat. It's been very good, very active. Loving it. And yeah, have a wonderful evening. And yeah, I'll see you all tomorrow for some more fun refactoring. Thanks, Pat. You have a wonderful evening. Bye-bye.